Hello and welcome to this presentation. You are going to be learning steel portal frame building design and member optimization to Eurocode 3 using all the new features in ProtaStructure 2026 version. And if this is the first time you're seeing our video on our YouTube channel, Solve Reason, consider subscribing to stay connected with us, like, and then share this video with our friends. Let us start. Okay, so we navigate to the new tab right there to create a new project, or we get to the file menu and then a new project option, click right there. So we have the project code already, steel portal frame design, so we just make it 5 from here, and then we scroll down to the Eurocode template. We select the United Kingdom Eurocode template, click on the OK option, and then you give it some time to prepare the Eurocode 3 template for design of steel portal frame building. Okay, so the code is ready. We start modeling or grill line set out. Now go to the modeling tab right here. We will use the option of orthogonal axis generator. Click on it and then click in space. So you have this property. So in these provisions, we'll be having the spacing between the stanchion to be 450 or 4,500 millimeters. So it's going to be into 3 provision, and then over to the axis level A provision, we'll have it to be 4 meters. So the steel portal frame structure is going to be more or less 8 meters by 70 meters here about. So I have just 4,000 millimeters into 2. So this is the grill line set out. All right, click on the OK option. Okay, so you have this. So you can see over here we have 8 meters, and then here we have 13.5 or 13,500 millimeters. All right, so this is the grill line set out for the steel building, or the steel portal frame building. Okay, so we have to navigate to the modeling tab. We start to model the steel stanchion from here. So just select on the steel stanchion. We click in the section manager, so we can select the right section. So over here I have a BS database, so I'll click in this provision and change it to Eurocode database. So I will be using HEA section, so I will go by this HEA 300 section. Okay, so this section will be optimized. I click on the OK option. So I just do a window over the grill line intersections in that direction, release my hand to have it placed, and then the same thing right here. So after which I can navigate to 3D through this story 1 provision and right click and change to 3D. So I have this. Okay, I want to set the story height. So to set the story, I click on this story, right click, and then go to the edit story provision. So this is the story height at default 3 meters. I want it to be 4,000 millimeters. Okay, so for the foundation depth, I want it to be 1,500 millimeters, and then the structural system is going to be steel. So these settings are necessary. Okay, click on the OK option and yes option. Then we'll start to model the beam rafter. Navigate to this frame options and then use the steel beam right here. So from here we choose the sections. We can use IPE 300, but let's check if it is an Eurocode database. Okay, so this is good. All right, we can go by this. Click on the yes options and then click on OK options. I will pick the first point from here and pick my second point right here. Okay, so I have on this beam I end and J end. So I'll navigate to 3D provisions. I want to elevate this at apex height of 2 meters. So That is the J end. From here, see I have J end. I go to the upward direction, which is the Z direction. I type 2000 millimeters. If you click on the update from here, it will be updated just like this. So from the arrangement and it orientation here, I want to move this I end downward with just minus 100, just like this. I click on the update from here, so you have something of this kind. Okay, I can make it just 50, so the offset will not be much. All right, this is good. So after which I close this window, I want to populate this steel beam rafter along the X directions. So I will just right click from here. I can use copy options from here, or having selected the beam rafter, you can see options to copy and also copy special. So I can just use the copy. I pick at the green line intersections, or I can use any point that I know is best for me. I pick that point and then take it to the next stanchion. Take it to the next stanchion, just like this. Okay, so after which I will now need to mirror it to, I will mirror to this other side. So I hold the control key to be able to select all of the steel rafter. Okay, and then I use mirror option, pick it. I pick the first point, pick the second point, click on the OK to have it mirror, just like this. Okay, so now if I select and double click on this rafter over here, you can see that there is no constraint at the M2 and M3. So we need to apply constraint at both I end and J end, because at the apex height there is much moment, and also at the connection between the steel rafter and the stanchion there's also much moment. Okay, so we applied a moment at those points. So how do you do that? You just have to select all the beam rafter and then right click, so you navigate to where you have the update beam end conditions, so both end inch, and then you apply it to selected beam. So once you apply it to selected beam, double click and check it again, you can see that it's been applied successfully. All right, so we proceed. We want to model the braces. So go to the modeling tab before then save this project. All right, so here is the brace. So just click on it. You select two member to have the brace interface, just like this. Okay, so if you wouldn't want, or you want to push these braces so that they can a little bit being offsetted, you can use these provisions. For instance, I type here 200. You can see this end is offsetted already. I type here 200. This other end will be offsetted. Likewise, the bottom provisions also, you can offset it. Just type in these provisions to offset them successfully. You check the brace profile also, and then you can also check the type of brace. So there are various types here. We choose to use the X brace. All right, so every other thing is good right here. If you want this to be split into two, you use the count provisions and type 2 right here. So this is split like this into 2. So I really want that. I need just one count. Okay, I click on the OK option to have it placed right there. So this can be copied as well, but I will just insert it accordingly, just like this. Let's come into these provisions. I will insert it right here, and then between these two stanchions, so we also have brace at the roof. So we just have to select the two beam rafter to have it placed, just like this. Just have to brace the members. So this is basically the wing brace. We are just applying it on this roof. Okay, so I click on the OK option. All right, so at this point we proceed to actually model the purlin. So I'll save this model just like this, and we proceed. Purlins right here, there are two ways to insert it, by first and last member. and then by selecting all the intermediate members and both end member. Okay, so we use the first one first and then the last member to have the purlins dialog just like this. So the profile of the purlins, if you click here, you can be able to choose your profile UPN 160. I'll go by that. I click on select under Eurocode database and OK options. All right, so other things is like an alignment is going to be on top of the profile. Right here, the spacing from here is going to be 1000 millimeters, and then your first member offset. So first member offset to me, I want it to be 300, and then the last member's offset should be like 100. Okay, and then if you scroll down here, every other thing is good. So come to the sag rod. There's a rod like this profile angle. I don't need it. Uncheck that. Okay, then every other thing, the diameter of the rod is 12 millimeters, and the rod count is 2. Okay, in each of the bear. All right, so I think this is good now by me. Okay, so if I want to extend the cantilever left and right for the purlins, I can choose to type 1000 millimeters for extend towards the left directions and 1000 millimeters extend towards the right directions, just like this. Okay, so if you want to create a gap between the continuous purlins, so a gap between this, you can actually provide it here, but I wouldn't want that. Okay, so we have the purlins properly placed just like this. You see, I continue to place purlins. I choose these options again, and then I pick the first and the last. Okay, that is not selected. Go back to, we can still mirror this if you wish to mirror, but I wouldn't want to mirror, so I want to just have to use the purlins options to place it. All right, so the previous settings is already there. We don't need to set any other parameters. Click on the OK options. So this is what we get. From here, we proceed to save the model, and then we apply clouding. So just select on the purlin. So you have the clouding just like this. So for the loads on the clouding, we consider the thickness of the roofing sheet, which will go by 0.5. 0.5 is a very good big I think it's quite very big. Okay, but this is being applied in terms of the load. So you can see over here we have 0.05 kilonewton per square meters. This is an area load, okay, for the roofing sheet. All right, so over here we'll leave all of this at default and click on the OK options to have it applied right here. I select on this other face and then get the load again, and then we use the same load value from here and click on the OK options. All right, so you see this is what we get. So we click on the save option to save this model, go to the loading, and then for the load cases and combinations, we have to apply it based on the Eurocode. So we need to generate combinations for steel members, okay, because we'll be having pedestal, which is a concrete member, and we can proceed to activate the wind loading from here. So we can apply it appropriately. Click on the OK options. All right, and then let's navigate and save this model again. We will click on the load editor from here. So we come to the load editor. So we are going to be using the full uniform load. So you click on the full uniform load. For the clouding, you right click to expand that. So that is the first phase and the second phase. Okay, select on the first phase, right click and filter it, so we can apply the load on it. So you can be able to view the top just like this. Okay, so at the first we have over here G load, which is the dead load. We have Q live load. We have XW, sorry, XX and XY. These are the wind load in the X and Y directions. Okay, so I will select the G load from here for the dead load, I will have 0.5 from here, apply it. So you just have to click. If you click on this once, you have the load just in the panels, just like this. Or you can do a window. You can do a window over the panel, like, let me, okay, it's applied. Show you that. Do a window like this, it will also be applied. So you can click right here to change it to 3D. So this is what we get. Alright, so this is how the load is being applied. Okay, and that is the dead load. We proceed with the Q load, and then for the Q load, we click on the full uniform area load. We are going to be having this to 0.07. So this is an area load. Okay, so we just have to select on that, just that way, just that way. So just go to the top so you can view all the panel. Okay, so we applied it just like this. Okay, after which you can get back to the 3D. So we are done with this panel. All right, we wouldn't apply wing load right here. Okay, so I will minimize this. Select on the panel, right click and clear filter first, and then this is what we have. Select this, right click and then filter that face, so we can apply the load here as well. So we also apply the same load value for the live load. Okay, so this is the top. Okay, does it mean, let me check something. Seems I'm having a load right there. Okay, no, so just do a window and release it to have it placed. Okay, and then go to the G load, which is the dead load. I will use 0.05, applied successfully. So over here, I just select on this, right click and then clear filter. So this roof is fully loaded, as you can see from here. Okay, after which you navigate to these provisions and click on the OK option to have the model in the modeling space, just like this. To confirm the load, save this model and then click on the load editor again. So if you did not see the load again, just bear in mind that the load you applied was not proper. Okay, so you need to check the program. Okay, from here we are good. We are good. What we need to do now is to carry out the analysis, or you do some material settings. So for the code we used, it's an Eurocode 3. So over here you see Eurocode 3 right here for the steel design code. Okay, for the concrete design code is Eurocode 2 from here, based on the code we selected earlier. All right, for the loading, to have Eurocode 1 for wing. So we have this code, so we didn't apply earthquake. Okay, so that is taken. Going to the foundations, we have the allowable soil stressed with 200 kilonewton per square meters, and that is what we are going to be using for foundation design. All right, we proceed. We want to look at the material. For now, click on the OK option and then save this model. Okay, before the material, we can apply wing load. So from here we have a wing load right here. I click right there, I expand these provisions. You notice all of the W, X and Y are 0 because wing load is not applied. So for us to apply wing loads, come to these provisions and click. So once you click here, the basic wing speed you provide here, and then from the basic wing speed you can be able to calculate the minimum wing pressure in kilopascal. All right, the minimum wing pressure in kilopascal. How do you calculate this? It is 0. You use 0.63 to multiply the square of your wing speed. 0.63 multiply the square of your basic wing speed. Whatever it gives you, divided by 1000, because this is kilopascal, to have it in this provision. Okay, so that is how you can calculate it. For the structural properties, we have reinforce concrete right here. You have to change it to steel. Yeah. After this, after feeding this, here we have the terrains and surrounding depending on the locations of the project. Okay, so this will actually entails the terrains of the site area. Okay, so from here you just have to click on the create win report after feeding in this provision, or you apply this successfully. So now that is being applied, if you click in these provisions, you're gonna have some values in the x wx and wy. Successfully click on the OK. That way the wind load is being applied successfully based on the wind speed at the construction site. Okay, we proceed. We want to carry out the material settings. So you go to the building setout and then you see a material. Yeah, click on the material for the steel grade we will be using. The purpose of this steel grade is for the pedestals that we are going to be applying shortly. So we use the steel grade 60. So for the rebar diameters, click in the edit provisions and then you have all of this. We go by minimum 16 mm diameters of reinforcement for the columns. All right, so the columns in this case, the reinforced concrete column in this case is going to be the pedestal. All right, we are yet to apply it. So that is what we get. If you have any beams from here, we can also go by 16 minimum. If you have any slab, because we'll be designing some basement slab. Okay, so we make progress. This is good. We click on the OK options and we click on OK. For the compressive strength of the concrete, we use 2530 from here, applied to all. Click on the OK options. Coming to the steel members for the columns, we are going to be using steel strength X275 is economical and is stable. Okay, so every other things here is good. Click on the OK. So here are the materials we have selected for this project. Click on the save options. You go to the review provisions and building check from here, so you can just start to check if you have any modeling error from here or would it have any. Click on closed. All right, so we proceed to the analysis tab and then we go by building analysis from here. So in this building analysis, get to the analysis provisions. We have already checked the structure. Just click on the building analysis. Oh, before building analysis, we are supposed to apply that pedestal. Okay, so you can cancel this for now. Click on closed. So for the pedestal, we have to move the grid lines to the bottom constraint of the column, and then we do that double clicking on the ST0 to have this. After we select on the stanchions and then you see insert pedestal. Okay, so just click on it once, it will be inserted. So if you want to insert the rest at once, you can actually select on this stanchion and then you have options to insert what I've seen here. Okay, so just select only one and click on insert. I wanted to insert it multiple. Okay, just like this. This is what I intended doing. Okay, so this is just a new feature in ProtaStructure 2026 version. I insert it just like this. So for the sections, you can always double click on it to change the section from here. I'm having 800 by 900, but this might be changed by the time we'll be designing the base plate. Okay, so I've applied the pedestal. We click on the save options from here, save the model, and then we proceed to the analysis, the building analysis. So we come over here, click on the building analysis. Okay, so we design, we analyze and design. So I have all of these provisions checked. Click on the building analysis. So let's give the program some seconds to carry out the building analysis successfully. Let's watch our ProtaStructure version 2026. We actually designed this steel structure. Okay, I think the design is successful, and then from what we have here, ready solid drift, satisfy limit in one direction. In direction 2, we are having some stiffness issue. Okay, so for these stiffness issues, how do you counter it? You need to provide a tie beam. Okay, so analysis is actually done, but for the stiffness problem, that means we need to apply a tie beam from here to here, from here to and then tie beam now, so it's going to be tie steel beam. Okay, but let's not go into that. Let's check the members. It has been designed basically. These major members you can see over here. It has been designed. If you click on this steel member design, okay, so you have this interface, and then here is the check for combined forces, and this is the U ratio. If you scroll down and then expand this, you also have the torsions and deflection check successfully. So all of this is good. Okay, but based on the U ratio we have here, we need to optimize these sections. Okay, so to optimize the sections is basically making sure that we have an economical section. So if you click on the change section from here, the section we use is 300 column section. So if we try to use 240 from here and then click on the OK, check the U ratio, we still have 0.5 as the maximum, so we can still reduce the section. So if you click in these provisions and then you use 200 at the sections, so this is optimizations. Okay, we have 0.9, so we can go by this. Okay, 200 sections. Okay, HEA. Okay, so click on the OK option, so that will be optimized successfully. So you can see that these sections become much smaller than every other section. So you can select on these sections and then choose to use match properties, and then click on the OK options, and then you can be able to match all of this one. Match this, and then enter on the keyboard. So this will actually nullify analysis, but I wouldn't want the analysis to be nullified. Okay, so I click on the no option so that it will not apply. That means we have to optimize this appropriately, like one by one. Okay, so over here you change from here, and then we are using 200 section. Let's see if that will be fine with this particular stanchion. Okay, this is good. So from here you can see design report. You can also see detailed report, all right, in terms of showing you some calculation steps. Okay, you'll find it here. Okay, so over here it could be a summary. Okay, click on the OK option. So I double click also on this. Sorry, we are optimizing the section. So all right, we click on the change sections from here, and then we use 200 as we use for other ones. Okay, 0.8, that's good. OK options, so select on this, and then we optimize this as well. We use 200 sections. Click on the OK option. Okay, so I'm done with the optimization of the steel stanchion as well as the steel rafter. Okay, so originally for rafter we were having a section IPA 300. So now we are using a 200 IPA section. For the detailed report, you can see it in this provision. So once you click right here, this will load the report. Okay, so if you scroll up just like this, these are the calculations, reports, and the checks successfully that can attach as your calculation sheet. Okay, click on close from here, and okay, so the same thing applicable to every other member. all other members have passed design successfully. Okay, so from here you can also see the statute here as well. All right. Okay. Now we want to design the base plate. For the base plate design, I would like us to pay close attention. So we move the grid lines to the ST0 right here, and I will select this stanchion. I want to start from the central stanchion, this one, because here we have much load than this other side. Okay? So just click on the insert base plate, and this will be opening the steel base plate design. So this is the base plate design interface. All right. So from here, when you are designing or making changes to these components you have here, you have to check the results to ensure that all of the statute is being checked green, and then what qualifies the statute to check green actually is when you are doing it correctly. Okay, but this is somehow complicated, but I will find a way of explaining it, okay, so that it will be well understood. All right, so let's just make progress. From the first one, we have this base plate and placement. Okay, so here is the material for the base plate. So the sections, which is the length and the width, and this base plate thickness. Okay, the placement is the anchor bolt. All right, so this you will use to adjust the anchor bolt positions and the spacing. Use this provision to adjust it. Okay, if you come down over here, we have the anchor and stiffener properties. So over here we have the anchor bolt diameter, so you can select in these provisions. So the anchor bolt tolerance, feeding in, and then the embedded length of the anchor, you can also provide it here. Anchor bolt projections, the top projections is 100 from there. The head plate length, which is the plate under the anchor bolt. All right, so this is the length, and there is the thickness. All right, you can also make changes. So coming to the foundation, shear, lunge, and weight. So over here you can select the grout material. It's the concrete material, so this is the strength, compressive strength. Okay, the grout depth you can also select, so you can choose to use any of these four. So let's start the design. I'll click on this particular base plate. I'll use this one. I select on this with a stiffener, just like this, and I will check from here. So you see a lot of all of this has failed. Okay, so you start from the first one. So the first one said anchor, combined tensions and shear check. All right, and then the second one is anchor shear check. So to minimize this, we just need to apply more resisting moment. To apply more resisting moment at the base against the stanchions, we need to apply the shear key. So let's first go to the foundation provision and click on this shear lock. Click it right here. So the shear lock key is being applied successfully. So let's get back. After applying this, let's get back to result here. So we notice some of this has actually passed its sign. Okay, and then some still failed. So get back to the base plate. We increase the base plate thickness to 40 instead of 20, and then we check also from here. You see we have base plate minor axis moment check as passed. We only have the base plate major axis moment. So for the major axis moment, and then we still have the anchor tension. Okay, for the anchor tensions, we just have to navigate to the anchor this provision and change this the anchor diameters to, can change it to 27 from here, and then we use the embedded lead. You can just use 500 from here. After which, let's check it again. We have 130, it has reduced. So you get back here, change this to 36. I will later explain to you the disadvantage of this, because we are trying to design it to code requirement. I see this as past design now. It is below 0. It's below 1. It's below 1 now. This is 0.3 because it's 66.92%. Okay. So coming to this, we can also get back to the base plate and see how we can increase the base plate. So over here, we could have 600 by 600 base plate, and then the thickness of base plate will have it to be this 55, and then if you check it from here, this has reduced, and we are still having concrete flow out check issues. And all right, so a lot of some of these issues, let's just get back to the sludge right here. Increase the weight from here to 10, that is the weight length, to 10. Also increase this weight length to 10. All right, so if you check it again from here, we are still having this to be, you see, base plate weight connections check. All right, 0.6. so we need to check the base plate, the profile plate weight truth, and the stiffener plate weight truth right here. So we can just make this like 12. So you just have to play around this. All right, and then you check, you see this as past design now. So we are left with just 3 options. So I'll play around the 3, but the most important one is this this concrete cone failure, and then the concrete flow out. Okay, so for that one, we need to increase the concrete sections. Okay, so just click on the OK options, and then come to the concrete section, select it, and click on the design sections. Okay, so if you click on the design section, already we have 800 by 700 concrete sections. So just make these sections to be. What I notice about this is that the sections must be within 1,000, 1 meter by 1 meter concrete sections. Okay, that is, I always see it as over design. If you click on the OK option from here, this is 1 meter by 1 meter. All right, so let's double click on the base plate and get here. If you check here now, you see that this has past design. So we are only having concrete cone failure check. All right, so this check now, we can't adjust the anchor board. So to adjust the anchor board, you can come to this anchor board provisions, and then you use come to this placement, use this provision to adjust it. Okay, so from here we can just choose to have 120 here. Okay, so if you have 120 here and you check these provisions, okay, it has actually makes this to fair. Okay, so we proceed to adjust most of this provision. All right, so after I've made some necessary adjustment to the base plate design parameters, you can see from here I have the status all as passed, and then over here you can see all design checks passed. Okay, so you must be able to meet this requirement for the base plate to pass design, but unfortunately the sections of the pedestal is about 111 1.1 meters, that is 1100 millimeters sections. Okay, for the pedestal, which is quite very large. I think that is uneconomical, but how do you see it? Just drop your comment in the comment sections. I think it's uneconomical, and you can actually use that section to control the concrete cone failure check, and then also the concrete flow out check. So this is these two right here actually control the sections of the pedestal. All right, so while the base plate major axis and the minor axis, you can actually control that using the plate section and as well as the thickness. Okay, so you play around it. Then for the anchor bolt tensile failure, you actually control that, increasing the anchor bolt diameter successfully in these other provisions. Okay, yeah, see I've changed that to 45. Okay, and then if you come back to the base plate right here, you can see the sections I've used so far, and then the thickness of the plate. Okay, which actually controls the which actually controls the base plate major axis moment check. All right, so all of that for the shear key. It also check the weld length. You can also check the weld length under the foundation, shear, lodge, and weight. So the weld length there. So you just have to play around this to make sure that this has passed design. Otherwise, I think it's not suitable. It's not suitable. If it doesn't pass design like this, it's not suitable. So from here, you can move to the report. So you can see all that you can print as a report. So this is design report summary. So material reports. So you can choose all of this if you wish. All right, and then click on the generate report. So this report will be generated for the base plate design. So this is more or less like the proper way to design base plates to meet code requirements. Okay, but the sections is quite too big. I'll show you another way which I think is economical as we make progress. Okay, so this is the base plate calculation report, and then you can see the Eurocode 3 used, okay, for the design. So we scroll down and then you see this is all the reports we had right here, 25 pages of report for the base plates. So you can print a PDF or Office. I'll close this right now. So now we are through with the base plate design. Just click on the OK option from here. So once you click on the OK options, you can see we have the base plate being inserted successfully. And then from here, you notice these column sections. If I just click in the section design right there, I have 100 sections of the columns, and the U ratio is 0.6. Click on the OK option. So that is what we have. We proceed to apply this to all other columns. For us to do that, if you use the match property, this will require you to carry out analysis again. Like if I select on this column, I use match property, I click on the OK, and I select on this one. If I enter, I think that has changed successfully. You can see the sections is pinned match. Okay, so I can match every other sections to this particular one that we have designed successfully. So just select all of this. So this is a new feature in ProtaStructure 2026 version. I click on the enter options to match them all. So to distribute the base plate, the same method, you can select on this particular one we have designed, and then we are sure it has passed design. Right click and then click on it property, and then also confirm that yes, this is still working. In terms of the result, everything has passed. Click on the OK option. Then you can right click from here and click on the copy options. So you just have to select on the stanchions and then you enter to have it placed just like this, you see. So just right click on this, click on the copy, and then select on the stanchion right here. You can select on multiple stanchions just like this, and then you enter on the keyboard to have it placed just like this, you can see. So this is how you actually design your base plate using ProtaStructure 2026 version. Okay, you can use other type of base plate right there, but ensure that anyone you used, the design is passed successfully. So click on the save option to save this model. At this point, we can move this to ProtaSteel to commence every other sections design. So we just have to navigate to the drawings and report tab right here, and then see ProtaSteel. Click on the ProtaSteel. So this will load. All right, here we go. This is ProtaSteel. So you can see what we have here. You can also design your base plates also in these provisions, but I think the most effective way to design your base plate is to use a new feature applied in the ProtaSteel 2026 to design your base plate, and then you can also use that to also try other sections if you want to get the calculation appropriately. Okay, which we'll be looking at that in the subsequent video. Okay, so how do you do that? You can come to the beam provisions, and then you can see we have idea statical here. All right, so you can use idea statical. This particular software is meant for connection design, idea statical. So you can be able to launch it through ProtaSteel 2026 versions, okay, and applied it. We will do that in the subsequent presentations. All right, so every other section you can also apply. The one that does not really need any section, that is any connection that is not actually a movement connections, okay, the ones that are non movement connection, like the purlins connections, like the brace connections. But for these major connections, beam to column connections that are orange connection and moment connection and the apex connections right there, the base plate, our advice should use the statical to carry out that design successfully, so you can get it designed properly. Or you can just design and check with the one we did using ProtaStructure, because that of the ProtaStructure, the column sections is giving us, and even the plate thickness, in fact the bolt, everything about it looks over designed. All right, but however, you have to meet code requirements, and that is what we did in the ProtaStructure module as concerned the base plate the design. All right, so every other connection works here effectively in this ProtaSteel 2026 version. The orange connections works just perfectly well, okay, so we can actually check these connections. You can check them and then see how the calculations is, if it is okay or not, or if it will require us to apply it any other additional board or choosing the board diameters. These are the things you need to check. So once you are done the design, you can just try it with ProtaSteel and also try the same thing with Idea Statical, and then you can see the differences, because I actually recommend Idea Statical because it's meant for connection design only, So for the apex connections, for the beam to beam connections, which is the apex connections, from here you can use any of these to actually apply it here. Select these two member to have it applied, just as simple as that. Okay, so all of these connections works perfectly well in ProtaSteel version 2026. Okay, it is quite a good upgrade of ProtaStructure. Okay, so let me minimize this or close this window and I'll save it from here and then get back to the ProtaStructure 2026 modeling interface. So we'll be modeling, as I said earlier, we'll be modeling the sub-basement beam as well as the sub-basement slab right there. So to do that, we are already at the ST0 right here. Can navigate to the modeling here and click on the beams, and then you can see the foundation beam as well as the sub-basement beam. Just select on the sub-basement beam. We'll go by these sections that we have here. Okay, so what you just have to do, you pick a 2-point R. What you can do, you can close this and then select you can select all of these members and hide them. Okay, there's an option to hide. If you right click, you can be able to hide this member. I selected, so you are left with this. Okay, so having left with this, you can now start to place whatsoever you wish to place. Okay, or you can as well navigate to the plan view to place them successfully. Click on the sub-basement beam, and then with the section selected, pick the first point, pick the second point to have it placed just like this. So this is the sub-basement beam. To brace the pedestal successfully. So most people don't actually consider these beams actually because of the cost. All right, but to provide a quality job, you need to actually bind the foundation like this together. Okay, for the sub-basement slab, you just have to navigate to the modeling tab and click on the slab right there. You change the slab thickness to 150 if that is the thickness you wish to use, and then go to the loading provisions. Additional load, I have 1 kN per square meters. For the imposed load, this is more or less like a workshop, so you can use this 4.0 kN per square meters for the machines that will be here. All right, so after which, get back to general and click on this sub-basement slab. So once you click on this sub-basement slab, it's going to take its place just like this, so you don't need any adjustment. You can see it's placed properly just like this. Okay, you can place it here, right? So this is the sub-basement slab. If you want to see the solid aspect of the slab, you can just have to navigate to the setout and click on the layers and color settings. So in this provision, scroll down to where you have slab right here, and then the slab ash. From here, you can change it to be more darker, just like this. I click on the OK, and this is what we get. All right, so this is it. To bring up the model in full, you can right click and show all. So you have all the model just like this. Okay, so this is what we have for you today. I hope you have learned one or two things in these presentations. Don't hesitate to drop your comment. If you have any comment at all, drop it in the comment sections, and you can check the description of this video. You'll see our group chat right there. You can join our group chat, ask questions, answer questions, and then we discuss right there. Okay, if you have not subscribed to our channel Freezing, hit on the subscribe button, like this video, and share this video with our colleagues so they will see the improvement in ProtaSteel and ProtaStructure version 2026. I think we'll be stopping here to be continued in the next presentations. Have a great day and bye for now.